In this lesson, we'll cover dealing with uncertainty. Specifically, we'll understand the difference between random and systematic errors. We'll calculate absolute and relative errors. We'll understand the difference between accuracy and precision, and then we'll understand the purpose of significant digits. Okay, so types of errors. So there are two different types of errors that can occur in measurement. The first type is a random error where a certain number or measurement can be off in either direction, and because it's a random error, the cause could be unknown or is inherently unpredictable. A systematic error is an error that impacts all numbers the same way. So that means that all numbers could be too high or too low. Okay, so going back to random error, let's say UNLV's computer system glitched and added $5 to one student's tuition and $10 to another and subtracted $200 from another, and it's just all over the place. There's no rhyme or reason to what amounts got added or subtracted. That would be a random error. A systematic error would be, let's say that the computer glitched and reduced everybody's bill by $1,000. The reason it's systematic is because it did the same thing to all of the numbers. Another types of errors to describe the size of an error are absolute errors, which takes the mistaken value minus the true value. That tells us how far off the mistaken is from the actual value. And relative error compares the size of the absolute error to the true value in terms of a percentage. So here, it would be calculated by taking the mistaken value minus true value divided by the true value and then times 100% to get it as a percentage. Notice the similarity between these two formulas and the formulas that we've talked about previously with absolute change and relative change. Example 1. The true price of an item you purchase is $18.98. You were billed for $19.98. Find the absolute and relative errors. Round relative error to the nearest tenth of a percent. So absolute error takes our mistaken value minus the true value. So this is the mistake, and this is the true. So we would be taking $19.98 minus $18.98, which would give us an absolute error of $1. When we talk about relative error, it would be $19.98 minus $18.98 divided by the true value. And again, in the calculator, I'm going to write a bunch of places because we want to make sure that we're rounding this correctly. 1998 minus 1898 divided by 1898. So I'm getting 0.05268 and so on. So we make it a percent first, so multiply by 100. And then now we round to the tenths place, which is going to cause the 2 to go up 1. So the relative error would be 5.3%. Accuracy and precision. So accuracy describes how close the measurement is to the true value, and precision describes how much detail is present in a measurement. So for instance, if we have like $106 versus 150.90, 105.9 is more precise because it's using more numbers to describe the value. Example 1. A person weighs 165.45 pounds. Their home scale gives weight measurements to the nearest 1/10 of a pound and gives their weight as 165.6 pounds. The scale at the doctor's office gives readings to the nearest 0.01 pounds and gives their weight as 165.61. Which scale is more accurate and which scale is more precise? So when you're determining which is more accurate, which one is closer to the true value? And when you're determining which scale is more precise, you're looking at which scale has more digits, okay, or more numbers that describe the measurement. So in order to determine which is more accurate, you could take a look at the difference between the true value and the mistaken value. In this case, let's see, 165.6 minus 165.45 would be a difference of 0.15. And 165.61 minus 165.45 would be a difference of 0.16. Okay. So in this case, the home scale is more accurate because it's closer to the true value. But the doctor's office scale is more precise because this gives it to the hundredths place. The home scale only gives it to the tenths, so the hundredths is more precise because it gave more digits to describe the measurement. Example 2. A person's true height is 64 inches. A tape measure can read to the nearest 1/16 of an inch and measures their height as 63 and 9/16 inches. A new laser device at the doctor's office gives readings to the nearest 1/10 of an inch or 0.1 inch and gives the person's height as 65.1 inches. Again, which measurement tool is more accurate and which is more precise? So I wanted to talk about this problem for a couple of reasons. Again, going back to mixed numbers, there's two ways to determine this as a decimal in your calculator. The first is to take 63 as the whole part and then divide 9 over 16 in the calculator to get 0.5625. So this would be 63.5625. The other way to do it is to change 63 and 9/16 to a mixed number and then do that in your calculator. To change it to a mixed number, you take 16 times 63, you add 9 to it, and then you put it over the denominator of 16. Okay, so either way will work for those. All right, so which measurement tool is more accurate, which is more precise? So let's take a look at the tape measure. The value 63.5625 minus the true value gives 63.5625. This is, minus 64 is negative 0.4375. And then the laser is 65.1 minus 64, which is an error of 1.1. Okay, so in this case, the tape measure is closer. I know that that's a negative number. You can also think of it in terms of like distance from the true value. That 63.5625 is closer to 64 than 65.1 is. So in terms of accuracy, the tape measure is more accurate. And which is more precise? Well, the tape measure is also more precise because it used more digits to describe the measurement. So you can have cases where you have two devices. The same device could be more accurate and more precise, or one device could be more accurate while the other is more precise. Just a note on significant digits, there aren't any problems in the homework on significant digits, but I did want to mention the purpose. Is significant digits in a measurement give us some insight into the precision of that number or how that number was being measured. Thank you for watching. If you have any additional questions, please feel free to reach out to me.